Hi everyone, welcome to homework 1.8b. I'm going to go through the homework and then honestly if I have time I'm going to go back to the last few questions in the classwork for to go over a couple things with that to make sure you feel solid on that. Alright, so we have Priya and here she is again buying raisins and almonds to make trail mix. Almonds cost $5.20 per pound, raisins are $2.75. Priya spent $11.70 buying almonds and raisins. The relationship between pounds of almonds, A, and pounds of raisins, R, and the total cost is represented by this equation here. It says, how many pounds of raisins did Priya buy if she bought these amounts of almonds? So what they want you to do is substitute the number pounds of almonds in the equation and then look for how many raisins, how many pounds of raisins she bought. Now we know from today that my PetSmart ad, sorry. We know from today that we can solve for the missing variable and then use that and substitute, and that'll make it faster every time that we want to calculate these things. So I'm going to skip down to D and let's go ahead and solve for R, and that'll give us an equation that we can then use to substitute in these things and make our lives a little easier. So if we have 520 A plus 275R equals 1170. And we want to solve for the pounds of raisins given a number of almonds. We're going to subtract 520A from both sides. Now this right here is being added, so we're subtracting it and moving it to the other side. And so this will give us, this will give us 275 equals 1170 minus 520A. So now I can, 275R, sorry. I can divide both sides by $2.75. And this will give me what R equals. So to find out how many raisins, how many pounds of raisins I bought, I can now substitute 2 into this equation, and it'll make it a little bit faster to solve instead of going through that process every single time. So I'm going to do $5.20 times 2 pounds of almonds, gives me $10.40 that I'm spending. 1170 minus that answer, minus 1040, is going to give us 1.3. And so I have 1.3 divided by 275 is going to give us 0.47. All right, so if she buys 2 pounds of almonds, she's going to buy 0.47 pounds of raisins. Okay, now if she's buying 1.06 pounds of almonds, let's try that one out. So 520 times 1.06. Okay, that gives us the cost per that particular amount of almonds. We have 1170 minus that answer gives us 6.188 divided by $2.75 gives us 2.25. So notice here she bought more almonds, and so therefore she bought less raisins. Here she's buying less almonds, and so that the amount of raisins was able to increase. Okay, so then you'll take 0.64 and you'll plug it in here for A, and we've already done D, so you're good with that. So you are responsible for doing C. You can go ahead and plug that in. Notice our amount of almonds has gone down, so logically your pounds of raisins should go up, and then that's a good way to check to see if you're on the right track, if your answer looks good. All right, number 2 says, here's a linear equation in 2 variables. Solve the equation first for x and then for y. Let me go ahead and give myself just a little bit more space here. And so if we have this, we're going to solve for x first, it says. So we want to get x by itself. So the first thing that I'm going to do is I'm going to move this constant and get together with the 123. So I'm going to add 31 to both sides because I want to cancel this out and make it 0. So this is going to be 4, 5, 1, 154. And so now I have 2x plus 4y equals 154. And I'm going to note that because that equation will be really helpful in a few moments. Let me make this a little bit larger for all of our sakes. All right, so we're solving for x first. So I'm going to next go ahead and subtract 4y. All right, because this term can be subtracted from here These cancel out to be 0. Now these are two unlike terms. 154 doesn't have a y with it, so I can't combine them. I'm going to leave them as is. Move my 2x equals 154 minus 4y, and then I can divide both sides by 2. All right? 2 divided by 2 is 1, so that cancels out. And I can leave this as 154 minus 4y, or I can go ahead and simplify this and do x equals 154 divided by 2 gives me 77. And then negative 4y, or minus 4y, will be minus 2y if we divide by 2. So that's solving for x. Now if I want to solve for y, interestingly here, I have a much simpler equation. So I can use this equation to solve for y. Let's go ahead and now I'm going to move the 77 to the other side. So I'm going to subtract 77 from both sides. I'll get x minus 77 equals negative 2y. Divide both sides by negative 2. And now I will have y equals. And again, you can either leave this as is, or you can go ahead and divide through. And so you would end up with negative x over 2 plus, because a negative divided by a negative, 77 divided by 2 is going to give you a decimal of 38.5. Okay, and so you can leave it as that. You could have also gone all the way back to the very beginning of this equation and solved for y, but again, this is already in much simpler terms here. So using this equation that we have and solving for y works as well, since it's equivalent. All right, let's take a look at number 3. So number 3 is asking us, they have ribs and chicken, and they bought a total of $17.01 worth of meat, right? Ribs are $1.89 per pound, and chicken is 90 cents per pound. That makes sense. Ribs would cost more than chicken. All right, so it gives us this equation, and then it's saying that they came up with these two equations. And how did we get there, right? So explain why it would be helpful to write this and show that they are equal. So let's start with solving for c. If we have 0.9c plus 1.89r equals 1701, and we're solving for c, we're going to first subtract 1.89r from both sides. And then this will cancel out to 0, so we'll be left with 0.9c equals 1701 minus 189r. And then I'm going to divide both sides by 0.9. And if we do that, we have 1701 divided by 0.9. It's going to give us 18.9, so that's where we got this. 18.9 minus 1.89 divided by 0.9. It's going to give us 2.1r. And that's where we got this second part of this equation here. Okay? So that's showing the steps to get from the original equation to c equals. Now, if we want to do the other equation, and now we have 0.9c plus 1.89r equals 1701, and we want to prove how we got here. Now we're solving for r. So I'm going to subtract 0.9c on both sides. We get 1.89r equals negative 0.9c plus 1701. I'm writing the 0.9c first, the negative 0.9c first, because we generally want to have the term with the variable first, okay? So I'm going to divide, and here we can see that they have it that way. Divide both sides by 1.89. And so they actually wrote out 0.9 and over 1.89 as a fraction. All right, so if we were to do negative 0.9 divided by 1.89, we would get this very long decimal, but we can check that decimal by doing 10 divided by 21 is also going to give us that very long decimal there, okay? So we know that that checks out, and then 1701 divided by 1.89 gives us 9, and so that proves that this matches with this term here. Okay? Ooh, ooh, oh my. Did not mean to do that. Very sorry. Okay. All right. So next up, we have a car traveling 180 miles at a constant rate. So that means that it's going the same speed the entire time. It says complete the table to show the rate at which the car was traveling if completed the same distance in each number of hours. So if it's always going 180 miles, but at a different amount of time, how fast is it going? Rate of travel means what is its speed? How fast is it going? Miles per hour. So if they're traveling in 5 miles, they do 180 miles in 5 miles. We can divide 180 divided by the time will give us miles per hour. And you know that because we have 180 miles over hours. So this is 180 miles per hour. If we do 180 divided by 5, that's going to give us 36 miles per hour. Then we're going to try it with the next one. We're going to do 180 divided by 4.5. Now, they're going the same amount of distance in a smaller amount of time, which means they should be going faster. So their rate of travel should be greater, and it is. It is 40 miles per hour. It's, again, a good way to check if your answer makes sense. All right, now they're doing 180 miles in 3 hours. So that's 60 miles per hour, and that makes sense because they traveled the same amount in less time, so they're going faster. And then, again, we should see this getting even faster because they did it in 2 hours and 25 minutes, so they are speeding at 80 miles per hour. Okay? And then it says write an equation right here that would make it easy to find the rate at which the car was traveling in miles per hour r if it traveled for t hours. So if our rate is r equals 180, that's our distance over time t. Okay, that would be the equation we're looking at. All right, number 5, bananas cost 50 cents each. All right, so 0.5 times the number of bananas we buy gives us how much the bananas would cost. And apples are $1 each. And it says that she buys apples and bananas that cost exactly $3.50. What are the combinations she could buy? So here, what are you going to do? Well, you have number of bananas, number of apples times the cost. $1 an apple seems kind of expensive to me, but you know, maybe they're really nice apples. So what you're going to do then is take each of these answer options and plug them in and see if they work, right? So if I were to say 0.5 times 2 bananas plus 1 times 2 apples equals $3.50, does that work? So 2 times 0.5 is going to only give you 1. 1 plus 2 is 3. That's not enough, so that does not work. Right? So for number 5, you're plugging in your answers and seeing which of those work to equal 350. If it equals 350, then it is an answer solution. It is a possible solution. You can go ahead and circle it. I'm not going to show you the example through all of that because that's just calculating things and plugging numbers in. All right? Plug in your number of bananas, plug in your number of apples, and see if it equals 350. If it does, it's an answer. If it doesn't, it's not an answer. All right, number 6. We have elementary school students going on a field trip with 40 adults. They're using 2 different types of buses to get to the destination. The first type of bus holds 50 people, and the second type of bus holds 56 people. Andre says that 3 of the first type of bus and 3 of the second type of bus will hold all the students and adults going on the trip. Is Andre correct? So that would be 50 times 3 plus 56 times 3, right? Because a 50-person bus, he says we need 3 of them. A 56-person bus, he says we need 3 of them, equals, we know there's 280 students plus 40 adults, so that's 320 people. Oh, what? It's auto erasing for me right now. Sorry, this is an equal sign. Equals 320. So our question is that true? So we have 50 times 3 gives us 150 seats. I don't know why it's doing this, guys, but it is. All right, plus 56 times 3, which gives us 168 seats, plus 150 is 318. So 318 does not equal 320, and it also does not give us more than 320. So no, this only holds 318 people, and we need a bus system, buses to hold 320 people. All right, let's take a look at Elena. Elena says that equations A and B are not equivalent. Write a convincing explanation as to why this is true. So why is this true? There's a couple ways that you can go about this. We can solve for x, and we can say 13 minus 5x equals 48. Let's go ahead and subtract 13 from both sides. We'll get negative 5x equals 35. Therefore, x equals negative 7. Okay? If I plug that into here, negative 7 times 5 is negative 35. That's not true. So we can say one reason is that negative 7 is not a solution for both, or they don't have the same solution. And we know that in order for them to be equivalent, they would need to have the same solution. The other way that you can do this is you can talk about those legal moves. If we subtract 13 from both sides, as we just did, I should never erase that, we get 5x equals 35, negative 5x equals 35, is not the same as 5x equals 35. And we can see that quite clearly because of that negative sign. So you could also say because of the negative sign, when we simplify and combine like terms, we end up with a negative 5x in one and a positive 5x in the other. They obviously then cannot be equivalent. All right, number 8. To grow properly, each tomato plant needs 1.5 square feet of soil, and each broccoli plant needs 2.25 square feet of soil. The graph shows different combinations of broccoli and tomato plants in an 18 square foot plot of soil. Match the points with the statement that describes it. So we're looking for A, B, C, D, and we're matching to the right 1, 2, 3, 4. All right, so point A is right here, where we have 0 tomato plants and 8 broccoli plants. So let's look. The soil is fully used when 6 tomato plants and 4 broccoli plants are. Okay, so this is 0 and 8, so this is not 1. 2, only broccoli was planted, but the plot is fully used and all plants can grow properly. So that's 0 tomato plants, 8 broccoli plants, so this matches with point A. Point B is down here, and it's below the line, okay, and it's where we have 3 tomato plants and 2 broccoli plants. So that looks like number 3, but it says after 3 tomato plants and 2 broccoli plants were planted, there's still space in the plot. Yes, that's true because it is underneath the line here. Point C is on the line, so it fulfills the constraints, and it is 6 tomato plants and 4 broccoli plants. So that matches very nicely with number 1. And then last but not least, point D has to be 4, but let's double check. Point D is right here, and that is 4 tomato plants and 6 broccoli plants. I really need to turn my notifications off. And then the plot is overcrowded. Yes, that is true because it is above the line, which means that we are not fulfilling that 18 square foot plot of soil. All right, almost done. Number 9, select all the equations that are equivalent to the equation 3x minus 4 equals 5. So again, you can manipulate the equation. We can add 4 to both sides. We know that 3x equals 9 will be one of the equations, so that's A. We can also solve for x and see if it works. If it works, then it's true, right? So letter B, if we simplify this, negative 4 and plus 4 is 0, right? And we would get 3x equals 9, x equals 3, so B also works. C, if I do x equals 3, 3 minus 4 equals 2, that is not true, so that does not work. 3 equals 9, not true, that does not work. And negative 4 equals 5 minus 9. 5 minus 9 does equal negative 4, so E is also a solution. All right, last one, Han. Han is solving an equation and he takes these steps. He says they are acceptable, but he ended up with equations that are not true, right? Because 6 does not equal 5. What can Han conclude as a result of these acceptable steps? So we get 5x plus 6 equals 5x plus 5, all right? And so then he went ahead and subtracted 5x from both sides, right? Okay, now what if he were to subtract instead 6 from both sides? What if he were to do this? And we would get 5x equals 5x minus 1. Is there any solution that will make that true? Well, if we divide by x, we're still going to have a problem there, right? And so A, there's no value of x that can make the equation true. B, any value of x can make the equation true. No, if I put in like 3, that's not going to work. So we know it's not B. C, x equals 6 is the solution to the equation. No, that is not true, because if we were to plug that in and try that, put 6 in there, you're going to get 36 on this side. And then 6 times 7 is 42, plus 5 is 47, minus 12 is not going to give you 36, is going to give you 35, right? So that doesn't work. And then 5, we know that that's also not a solution. If you plug that in, you're not going to get the same answer. So the only possible solution is A, because you would ultimately end up getting, in this case, 0 equals -1, but you're going to get some statement that is not true and therefore does not work. Okay, that's all of your homework. Your code word for today will be, what will your code word for today be? Your code word for today will be PetSmart, since I had an ad today. All right, your code word for today will be PetSmart. I am at this point going to go back into the classwork for numbers. I'm going to look at numbers 4, 5, and 6. If you want to work through those with me, you can. If you don't, you can stop here. So let's take a look. We have a situation. The yogurt at Sweet Delights cost 65 cents per pound and 10 cents per topping. The total cost of the purchase was $1.70. All right, so then we have this equation, and this is correct, right? It's 65 cents per pound, P for the pounds, and 0.10 cents per topping for T, and that total is going to be $1.70. Then he makes another equation, and he says that this T equals this. What is the error? So in this case, it looks like he moved the 65 cents to the other side, so that part is good. But then instead of dividing by 10 cents, he multiplied So he did the wrong operation here, okay? What is the correct second equation? The correct second equation would have been T equals 1.7 minus 0.65p divided by 0.1. And again, you can simplify that and do 1.7 divided by 0.1. Oh my gosh, I get so many ads, you all. I need to take care of these notifications. Equals 17 minus 0.65 divided by 0.1 is 6.5p. So you can also write it as that. That would be acceptable as well. You can leave it with that fraction as well. So what might Tyler have been thinking that led to his mistake? He used the wrong operation. Okay. All right, number 5. The perimeter of the rectangle, twice the sum of the length and width, is 13.5 inches. Let L be the length of the rectangle and W be the width of the rectangle. So he makes this first equation here, and then he says if he solves for W, he's going to get this. What did he do wrong? Okay, so if we're solving for W, we would first do L plus W equals 13.5. We're going to divide both sides by 2, because if we divide both sides by 2, this 2 divided by 2 will cancel out. And so then if we want to solve for W, we would do W equals 13.5 divided by 2, subtracting L. So his error here is, 1, he forgot that the 2 is being multiplied by the whole thing. So he did not consider that the 2 has to be multiplied through. Okay, because this is distributive property, so that 2 applies to the W as well as to the L. So a second equation that he could have written, we wrote over here, is W equals 13.5 divided by 2 minus L. You can also go ahead and again do 13 divided by 0.5 divided by 2. Give yourself 6.75. That would be fine as well. And again, what might Tyler have been thinking that led to his mistake? He did not consider the distributive property, right? The importance of distributing that 2 through the entire parentheses. And so therefore, if you divide one side by the 2, you have to divide the other side by 2. So you can say distributive property. You could also say he didn't divide both sides by 2. But again, he has 2L here, so he did consider that the 2 has to be multiplied by the L, just not by the W, which is why I'm saying distributive property. All right, number 6, for a fundraiser, a school is selling flavored waters for $2 each and pretzels for $1.50 each. The school has a goal of $200. Tyler made the first equation correctly. 2W, 2 times the number of waters, plus 150 times the number of pretzels equals $200. Then his second equation is here. So the error is he subtracted 2 from 200. He subtracted 2W from 200. All right, the second equation that he could have written is he could have written 1.5p equals 200 minus 2W. All right, so that's the second equation that he could have written. And his mistake is he combined unlike terms. So 200 does not have a W with it, but 2W has a W with it. So these cannot be combined to make 198 because of this W. If this had a W here, then it could be, you could subtract it, make it 198W. But because there's no W with this 200, that is not something we can combine. They have to remain separate, and therefore we write them as such. Okay? All right, that's it. Have a wonderful evening, and I will see you tomorrow.